Good morning, good afternoon, and welcome to the first VMware Tanzu webinar of the new year. Happy 2023. And I would like to just welcome three fine gentlemen for welcoming us into our first webinar of the year. Michael Wright, Howard Twine, and Gregory Green. But before we get started, we do have a few housekeeping items that we'd like to cover. First, we'd love to keep this as interactive as possible. So if you have any questions for us, please submit them using the Ask the Questions tab below the presentation screen, and we'll do our best to answer them live throughout today's presentation. In addition, we know that you guys are here to hear from us, but we love to hear from you. So leave us feedback using the Rate This tab also below the presentation screen. And if you didn't notice, this is the second part of our series talk, and we will be coming out with more versions of this in the future. So please keep a head up for as these events start coming live on our events page. So without further ado, we'll hand it off to today's speakers.
Thank you very much. So today's talk is the first in a couple of series that we're going to cover some retail aspects. We'll dive into that in just a moment, but just run through some introductions. My name's Howard Twine. I'm a product manager within VMware Data Solutions. I'm responsible for RabbitMQ, both the open source and commercial offerings, and based in the UK.
And my name is Mike Wright, Senior Solutions Architect on the VMware Edge team. I focus mainly on modern applications and bring them together at the edge, zero-touch provisioning at the edge, retailers, manufacturers, industries like industrial and things like that, how to get applications distributed to potentially thousands of endpoints and manage important business data underneath those applications at those sites.
And hello, everyone. My name is Gregory Green. I am a solution engineer, part of the pre-sales team for our data solutions, which includes products like RabbitMQ, Gemfire, Postgres, and Greenplum, which we'll talk about during today's chat.
Thank you, guys. So today's agenda, we're going to walk you through some of the key aspects around supply chain and inventory management for retail. And I'm just going to give you an introduction, set the scene, so that you can understand some of the challenges that retailers are facing in today's landscape. And then I'll hand over to Mike, who will put some edge native context to what our solutions can offer. And we'll walk you through later on some of the architectures that you can adopt that can be adopted to improve supply chain and inventory management overall. And then at the end, we'll have time for questions before we wrap up. So let's get cracking with this. And in order to kind of understand the context here, I wanted to paint a picture of the increasing competitive nature that retailers are facing, and in particular brick and mortar retailers. In 2020, more than 12,000 stores in the US shut down during the COVID pandemic. And in the UK, that equated to about 9,000 chain stores that closed. As a result, retailers are constantly looking at more intelligent ways to generate revenue and to better understand their customers' buying habits. But it's not a simple task, especially when you take just one component that retailers are facing in supply chain and inventory management. Retailers face perhaps what is their biggest challenge since the evolution of online retailing. And to put this in context in terms of the amount of spend in store with brick and mortar retailers compared to online, 65% of household shopping budgets in the United States are spent in store. So there's still a significant slice of the market, which makes it all the more important for retailers to properly understand what's going on with customer habits. And the evolving customer demands, customers are very fickle in the respect that if the right product isn't on the shelf in store at the right time and at the right price, it's very easy for them to go elsewhere. So, how do you get those products on the shelf in the right quantities, especially when shipping costs are fluctuating almost daily? And you take factors like the cost of a shipping container. For example, in 2020, a 40-foot shipping container cost about $1,300. In September of the following year, in 2021, this had risen to over $10,000. And the fuel costs, the increase in fuel costs currently, and interrupted manufacturing from suppliers through the pandemic in various parts of the world, and a skills deficit with lack of drivers, etc. These really start to compound the issue. And sales data from retailers really needs to be up to the minute in order to provide accurate and reliable business intelligence. So with that in mind, I wanted to take just a sort of a brief view here at what is a sort of traditional and a fairly old school approach to retail supply chain and inventory management. And typically stores would upload daily, weekly, or monthly sales reports to a central corporate data center and a database within that. Stock replenishment for that on a daily, weekly, or monthly basis, that would be handled by a regional distribution center that's connected to that same corporate data center. There may be trend analysis that's performed around sales data, and that would influence various stock levels at regional distribution center. And marketing teams might also define specific restock or new stock based on upcoming marketing campaigns, etc. So there would be an influence there. Data resiliency in this kind of old school topology is would be something like a daily tape backup or something like that, which would be ridiculously crude. But perhaps most importantly, certainly in today's landscape, this is not a particularly portable solution. So that's one of the many challenges. But just taking this architecture into account, the business insight for analysis teams, this ends up being sort of stale. The data that's generated can be stale because it's not generated in real time. The data also becomes disparate across the wider organization. There's little or no resiliency, as I mentioned, and a daily tape backup is not a good business continuity plan. That single database is constantly being hammered from all angles. Sales, marketing, analysis teams are always hungry for yet more data and more detailed data. The more data that's generated, especially at source, and from a retail point of view, this would be point of sale information. The more data that's generated, the more people further up the organization are going to want to do something with that data. And the more people that want to use that data, the greater the need for the quality of the data to be as high as possible. And it becomes a self-perpetuating situation. Additionally, if a retailer wants to add artificial intelligence or machine learning tools to this sort of architecture, if these tools are going to be used, then the surrounding infrastructure for these tools need to be scaled. It needs to be scalable, or at the very least, scaled accordingly at the start. And if adopting AI or ML, there may be a need to certainly train those models, and you want to train those models at the data center where there's that large amount of data and high quality data that's as fresh as it can possibly be. But then the predictions would be run at source, which in the case of a retail outfit would be in store and at point of sale. So how can you address these challenges and provide ultimate business flexibility that businesses need today? So with that in mind, I'm going to hand over to Mike now, who's going to talk about the edge native things to consider, as well as run through a short demo. Mike.
Thank you, Howard. So yes, I'm going to try to contextualize this problem that we're trying to address here with data at the edge. And one thing that's emerging in the industry is this new terminology, edge native, or even edge native applications. And we compare this to cloud native. Cloud native is what's been born out of the modernization efforts since about 2010, going from monolithic applications to cloud native and microservices and DevOps and those sorts of things, delivering things in data centers and cloud. And so when we look at edge, we have certain factors that constrain some of those things we've learned over the past few years from cloud native. I'm not going to read through all of these, but some of them are pretty important to call out. And one thing in particular to summarize all of this is that in the cloud native world, as an app developer or somebody that is concerned about where am I going to store my data, protect it, there wasn't this concern about the infrastructure. We didn't really have to think about, and that's the whole point of cloud native platforms, is to abstract the developers from that concern. But when we get to edge, we do have to design according to some constraints around the network, around the compute resources, and also take into consideration some of these devices, when put into an industrial setting, they do have to have direct access to a COM port or a serial port or those sorts of things. And in retail, we see this on this adoption of things like computer vision and GPUs as another source of information that the apps need to reference at the edge. But importantly, if we're managing data that is generated by that store or that retail location at that brick and mortar site, that is important data that needs to be protected and propagated back to the corporate data center or cloud, we're sometimes trying to design an app architecture around no HA for storage for stateful services. So what do we do in the cases when we can't rely on our Oracle database running inside the back office of the store? We need to figure out a way to get that data as quickly as possible, network allowing, to some place where it's better protected. And that's where we see a lot of emphasis in this edge native app architecture on event streaming and how we flow our data. So this all allows for us to potentially control the costs of what we're doing at the edge, but at the same time have business applications managing very important data and having that data protected in the best way possible. So as I go further here, I'm going to dive into a very specific example that we can talk through to, even make this hit home even closer. So, we've got in our demo here, we've got an example of some edge native services. These apps are built using .NET Core. The reasons I picked .NET Core to build these applications is because they're lightweight. They fit perfect for an edge native environment. But I'm also going to rely on RabbitMQ and the client APIs that come from .NET to support that. Now, I could have used Spring at the edge. One thing that folks who are app architects or they're managing their edge stack might think about Java and edge is they might think, hey, Java is heavy. It takes up a lot of memory and compute and things like that. I've got this big bloated application that I want to run, and Java just takes up too much. Well, VMware is also well known for Spring, and with the adoption of GraalVM, we now have the ability to build Spring Java applications compiled into low footprint binaries. But for the purpose of this demo, I stuck with .NET, and I'm going to highlight some of the use case here, and I'm going to leverage RabbitMQ at the edge. And the great thing about RabbitMQ for this case of no HA storage or connectivity from edge to data center, it becomes an issue. There is a new feature within the past couple of years added to RabbitMQ to support streams. So you now have this multi-purpose event bus that can handle the traditional queuing and brokering, but as well now can handle the streaming functionality that we need to have high throughput streaming of events that are coming in at a retail location. And then also in conjunction with that, Rabbit supports this concept of shovel. Shovel is a WAN replication feature of RabbitMQ that allows you to withstand breaks in that connectivity from one RabbitMQ cluster to another RabbitMQ cluster. And in this case, we're talking about one-way communication from our stores, our edge sites, to a corporate data center, with the expectation I'm going to lose connectivity from time to time, or it's going to be very slow. So we've got a demo scenario here I'm going to walk through that kind of showcases some of this pattern. There's all kinds of different patterns that you could take a look at when you build your edge native applications. But like I said, just to reemphasize, one of the key components as it relates to data is how do I leverage event streaming to make sure that I have the best case scenario of saving my data, even when I don't have redundancy at the underlying storage tier. So I think I got one other slide. Yeah, so edge native, what does it really mean for edge native? You know, this, I think it's always helpful to put this in visual context. You know, in some cases, we might be talking about a very small, singly deployed device, like an Intel NUC, what's depicted in the left, or we might be talking about a more sophisticated, robust stack of infrastructure that's depicted on the right. In a lot of cases, the cost to do what's on the right-hand side are prohibitive for many of retailers that are trying to address potentially thousands of brick and mortar locations. So we need to be flexible in how we architect based on the capabilities or limitations of the infrastructure that's actually at the edge. And so in this demo, I'm going to show you an example of an application that, like I said, is written in .NET Core. It uses message streaming from RabbitMQ, a new feature within the past 2 years, where I'm going to propagate point of sale transactions from that edge, and I'm going to use the shovel feature to propagate those point of sale transactions onto some subsystem of corporate functionality back in the data center. The nice thing about streaming along with shovel is streaming is meant to be WAN friendly with shovel. It ensures the data safety in case of connection and node failures. And it supports AMQP 9.1 and 1.0. And streaming is more focused, if you're familiar with queuing is more focused on routing those messages as appropriately to different destinations. And one of the things that, if you know RabbitMQ well, that the performance implications of a RabbitMQ that gets backed up, if we're talking about queues, it degrades the performance because there's a higher pressure on memory. Streaming takes that pressure off and leverages disk and allows for a much higher performant throughput of events. And it also allows for long timeline storage or time replay storage of those streams on disk. So now you have the ability to choose between traditional queuing or that streaming use case that you might find in other solutions like Kafka or things like that. And so at that point, I'm going to go through my demo. So one thing I wanted to revisit, just to contextualize this more, in some cases, we might have these edge devices that are really small devices that, might even look like an Intel NUC, in some cases. And on that, we might have, just a limited amount of CPU and memory. Like if we look at this particular case that I'm managing the app deployment to, it's only 4 CPUs and actually has 8 gig of RAM, but that's one context of edge. Another context of edge is we might see, vSphere running inside the retail location on a single physical host. But in this case, obviously, we don't have shared redundant storage. We're not very well protected, in the case of an outage of this single device. So I do need to worry about getting my important business data off of this use case as quickly as possible. If we have more like 2 hosts at the retail location, then maybe we can rely on things like vSAN with a remote witness at the underlying storage tier. But still, I'm concerned about getting my business data off of those edge locations as quickly as possible. It's only when you get to the ability to support true quorum-based storage systems or databases that you can feel a little bit more relaxed about what you're doing with your data at the retail location. You have that redundancy, and a lot of technologies are built around this notion of 3 or more, in a quorum-based, including the vSAN solution. So that's just contextualizing, what infrastructure scenarios could we be talking about when it comes to edge? Well, in my case, this application architecture that I'm going to demonstrate, I've got this app deployed in 3 locations. This is going to kind of showcase the points that I'm making about using .NET Core and RabbitMQ to move these events off of the edge site as quickly and safely as possible. So in this case, on the left-hand side, I've got the application deployed at 2 different brick and mortar store locations, and I might have transactions coming through for peanut butter on one side, and maybe at a different location there's a run on jelly at this store location. So at this location, what's happening through the app is that I'm not writing to a database. I'm not writing to disk. I'm writing to a stream running RabbitMQ at this edge location.
And Mike, are you showing your screen?
Oh, I'm sorry. Am I not sharing? Oh my gosh. Did I go through all that? Oh wow. Sorry about that. Well, I messed up that. Let me go back to the beginning here. So I was showing my screen. Basically, what I was going through is the context of our edge sites here, and basically I was explaining your edge might be an Intel NUC single small device. It could be something as more advanced as vSphere running on a single host in the back of the store. Like what I'm depicting here on a single host, but in that case, I don't have redundant storage. You might be a little bit better equipped with 2 nodes, and in this case, you could leverage things like a remote vSAN to have that redundant storage. But still, you have to be very concerned about how you write business data underneath your applications. And so what I was moving into here is then the demonstration of this application, which is written in .NET. And if anybody's interested in seeing how this is built, there is a public repo out there that we can share after the presentation where this code is available. And it demonstrates the use of RabbitMQ and using that streaming functionality to propagate those transactions from different edge sites to the data center. So in this case, I've got 3 windows open where I have the app deployed in 3 different places, 2 edge locations, and then 1 data center. And I'm basically simulating, purchases are happening at different registers at one retail location. Let's say the peanut butter SKU at location 1, the jelly SKU at location 2. And all of those transactions can be funneled back centrally to a RabbitMQ running back in the data center that can then be consumed by ERP type systems or any other inventory management processes that you have. And that's where Greg is going to take over and describe some of the things that we can do back in the data center to help support that inventory management flow of retail locations. So Greg, I guess I can turn it over to you at this point.
Awesome. Thank you for that, Michael. Just waiting for my screen to reload. Okay. All right. So this diagram provides a holistic view of edge native services and applications and data services running within a central hub. And what I want to highlight here is the platform of choice to run applications and data services in for our showcase demo is based on Kubernetes. So you may be asking, why would you want to use something like Kubernetes? Well, it simplifies what we call those day 1, day 2 operations. Day 1 meaning I want to provision an instance of a server or container to run my applications or my data solutions. And you can actually put the power of provisioning those instances in the hands of your developers, your application teams, and your product owners. And the infrastructure itself would maintain the health of or everything that's running on the platform. So doing things like doing self-healing based on the desired state of your applications or your services. Also scaling the number of instances of your apps or your instances of RabbitMQ, for example, just update, providing an instance count to the Kubernetes infrastructure, and the infrastructure would make sure that it provisions those number of instances based on your desired state. But not only provisioning them and running them, but making sure that they are running highly available. So if there's an issue with one of your apps, restarting them to maintain that desired state. And a consistent fashion is all part of the infrastructure. Now, as long as you have something like Kubernetes installed, it really makes the user experience of provisioning and maintaining your services consistent, because it's just Kubernetes. And it could do powerful things like making sure that every one of your pieces, your processors, is up to date, right? When you're doing upgrading, implementing patterns like doing rolling restarts or even having blue-green deployments is something that can easily be handled by Kubernetes. And for our data solutions like RabbitMQ and Gemfire and Postgres, we're going to talk about a little bit more, you can implement something like a operator pattern, which is basically an intelligent piece of software running within the Kubernetes platform that simplifies or knows the details of how to perform those day one and day two operations for the specific data services. Now, for our data architecture, VMware has a portfolio of data solutions, including RabbitMQ. And RabbitMQ can really play a huge role, a significant role in reliable delivering those point of sales transactions from the edge to a central location, but also handling events that happen between applications. You can use something like Gemfire for real-time data processing. So this allows us to quickly handle those point of sales transactions and doing things like determining if the current available count for peanut butter is approaching a desired reorder point. Don't wait till there's no peanut butter left at the store before you start a reorder. Do that in real time based on real time based calculations. But the determining what's the appropriate reorder point for your products like peanut butter and jelly, in addition to how much should I order whenever I get to a particular level, should all be based on analytics. And you can use an analytical database like Postgres and Greenplum that will predict things like, for example, what's the average number of sales, what's the maximum amount of time it takes to reorder those products based on data that's coming from the store. And you can store those, you can derive those prediction models and store them back into Gemfire so that you can, again, make quick decisions based on analytical data. Now, for the applications in this showcase application that I'm going to show you quick later, I'm using Spring. And you may be asking, why would you want to use something like Spring? Well, Spring has been in production used for a significant amount of time now. And there is a Spring One conference that is coming up soon where you're able to hear from customers and experts in the field on how people are building really interested and stable, powerful features, all using the Spring Stack. And as a developer, I really find it really easy to develop my applications and my services by using Spring. So, for example, if I had to build a responsive, scalable, resilient web application, I could utilize a Spring project like Spring Web, or integrating and utilizing something like RabbitMQ. I can utilize Spring Cloud Streams, and having an abstraction layer to handle data access patterns for databases like Gemfire and Postgres and Greenplum. I can utilize Spring Data. Now, for event-driven architectures, again, talking a little bit more about Spring Cloud Streams and its ability to abstract RabbitMQ, I must admit, for years I put RabbitMQ on my resume just because I knew Spring Cloud Streams. But as I've been learning the details of RabbitMQ, the different messaging types and the queue types that it supports, how it handles a reliable delivery and high availability, and all its various configuration options that are available to developers, I now have a better appreciation of how beautiful and how powerful an abstraction layer is, like a Spring Cloud Streams. Because as a Spring developer, all I need to do in order to consume point of sale transactions, for example, is to implement a single interface with a single method. So my accept methods is passed in my point of sale transaction business domain payload. And the framework itself handles making connections with RabbitMQ, converting those RabbitMQ payloads to my point of sale transaction domain objects, and even doing things, having things like error handling. Like, for example, if I cannot store the data in Gemfire and Postgres for whatever reason, the framework can implement retry logic. So I can, again, to retry to save those transactions at a later point in time. Or imagine if I get something that's put into RabbitMQ that does not conform to the point of sale transaction data structure, right? Malformed data. So there are things built into RabbitMQ like dead letter queues, which is basically a separate storage area where you can move messages for later remediation. But again, all of those details of error handling and retry logic is all built into the Spring ecosystem itself. So I have to do less coding. And data consistency is very important too. And each one of our data solutions like RabbitMQ, Gemfire, Postgres, and Greenplum has this notion of transactions. That means I successfully process a message from RabbitMQ, or I successfully save the data in one entity within Postgres or within Gemfire, or if there's any kind of issue, I should roll back, or in the case of RabbitMQ, not acknowledge the message, or in the case of Gemfire and Postgres, to not save the data. And again, Spring knows all of the low-level details on how to commit or roll back these transactions, a single unit of work. And that's important, especially when we're talking about inventory management and forecasting of our models. We're basing this based on data. So if there is a significant number of transactions, a point of sale transactions that we cannot process, right? There's a cost associated if that data is inconsistent between any one of our systems. Now, as I mentioned, we can use Gemfire, which is an in-memory database for real-time processing of transactions. And Gemfire is a distributed NoSQL database. So it can support our use cases if we need high availability and fault tolerance, meaning we can have multiple copies of the data across multiple servers. But since it's in memory, we can do a lot of the in-memory processing in real time with low latency. Now, you can imagine as you have a store that's been in use for many, many years, there might be a significant amount of transactions, right? And it may be infeasible from a cost point of view to keep all of the transactions since the beginning of time all in memory. But with a solution like Gemfire, what you could do is you can keep the most recent data. Imagine keeping a couple of months or a couple of years worth of data in memory in Gemfire, and use something like a writer or a write-through pattern, such that every single transaction can be stored in your Analytical database in Postgres. And you can expire based on policies, time to live policies, that older historical data, again, just keeping the data that you need in memory in Gemfire. But when you expire from Gemfire, they will be persistent and available in your Analytical database. And if you ever need to reload those historical records, you can use another pattern or another component of Gemfire, which is a loader, which can read that data from Postgres back into Gemfire in memory as needed. Now, when you are storing your data in Gemfire first, Gemfire has lots of powerful features to implement change data capture. So, for example, you can have listeners that are, one listener in particular that's registered with Gemfire, which is something called a continuous query listener. This is probably one of my favorite features of Gemfire. So what you essentially do is you register a query with Gemfire. So anytime a record is either created, updated, or deleted that matches a query condition, my code will be notified in real time asynchronously. So I can do things like, for example, in this particular query, I'm looking for in the store product inventory, if the current available amount is less than or equal to a reorder point. And when that happens in real time, I can immediately submit a reorder or request. Now that field, which is the reorder point, or determining how much to reorder for a particular product, as I mentioned before, it should all be based on analytics, on historical data. And you can use a database for deriving those workloads or those predictions. And again, you may be asking, why would you want to use a database for that level of analytics? Well, a lot of times people are building analytical workloads. They're writing their code in Python or R, and they're processing data over multiple data files. Those data files might be different locations. They may be in different formats. And in that case, you need to make sure there may be an issue with controlling and having standards on building those analytical workloads. But with a database, you can use SQL as the standard, right, to access data in tables. And you can use the power of the database to maintain data quality. So, for example, making sure that certain records that are saved into your database table are unique based on a particular field, or making sure that a particular field is non-null, or if it's a different data type, whether it's a string or a number, and doing statistics. So, for example, we will be basing our reorder point based on the average number of sales for a particular product, right? So, doing like time series based averages, maximums, even doing percentiles like 90th percentile or 99.9 percentile, you can use the power of the database to calculate that statistics instead of relying on third-party libraries. And the database can scale with the data, right? So especially a database like Postgres, right, where you're performing your analytics based on data stored in disk. And in general, a disk is much cheaper than in memory, right? So if you have data that is less than maybe 100 terabytes or hundreds of terabytes of data, you can easily manage that within a single Postgres database. But when your data gets larger and larger, maybe over 200 terabytes of data or even petabytes of data, you want to think about spreading the evenly processing of that data over multiple servers, so you can introduce something like Greenplum, which is based on Postgres. So to your applications, your analytical applications, whether it's Postgres or Greenplum, it's really abstracted to them, right? Greenplum looks like Postgres to your SQL-based clients. And then for those machine learning, artificial intelligence workloads, again, for this particular example, we are performing our predictions based on the actual store data so that we know that it's accurate, right? And if you want to have more advanced workloads written in your favorite programming languages like Python and R, what you could do with something like Postgres and Greenplum, you can turn them into that Python code, that R code, you can turn that into a SQL-based procedure or a function that can be accessed via a SQL operation. And your data science can use the analytical database and using tools like Juniper Notebooks to perform experiments, right? And also to tune the forecast models based on the data that is coming in to the analytical database, and or utilizing a library of statistical routines using something, for example, like Apache Madlib, which when you run it and enable that into a database like Greenplum, which is multiple, you can run it over multiple servers, those workloads run in a parallel fashion. All right, and what I'm going to show you is an example application that this application is sort of like it's a portal for an inventory manager. You can get insights into the current levels or the amounts that are available at the store. And it also shows you the forecasting models, right? In terms of the daily sales expected for a particular product, the lead time, which is basically typically how long it takes for that product to be reordered, and what is based on the model, how many items we would resell or reorder when the current available levels are less than the reorder point. And there's various Spring-based applications. There's a Spring-based application that's rendering the UI. We're using RabbitMQ to process the transactions. So the transaction consumer is storing all the latest and greatest transactions in Gemfire. It's also there's also this inventory forecasting application that is deriving the prediction workloads based on data stored in Postgres. And we have this reorder listener, which is a continuous query listener. So as soon as the product, the current available levels goes below the reorder point, you'll see a reorder recommendation. Okay, so let me go ahead and let me share my screen. All right. So here I have the application. The application is running in Kubernetes, and we see that we have a reorder because of peanut butter, because the quantity is equal to the reorder point. Now I have another application that will simulate. This is basically simulating data coming from the edge and stored within Gemfire and Postgres using RabbitMQ. So in this case, what we're going to do is we're going to simulate the order. A truck has come to the store, and the current available amount of peanut butter is updated from 45 to 47. And for this example app, what it does is it removes the reorder or recommendation, right? But now, as we mentioned, we are using a continuous query convention. So now I have another UI, which basically going to simulate transactions or the selling of peanut butter. So once I hit this a couple of times, basically I'm submitting this transactions, it's updating the counts, being visualized to the inventory manager. And as soon as the inventory amount, the current available amount is equal to the reorder point, then we see the reorder has been recommended. Again, so that's using the power of continuous query, also using RabbitMQ for event-based processing and deriving all of this statistical information from Postgres. Okay. All right. So let me go back 1 second. All right. So in our slides, So, I mean, that's pretty much our demo. So we'll see if we have any questions at this point.
Great. Thank you, Greg. And thanks, Howard. Thanks, Mike. We do have a question here that we'll note, but I do just want to lead folks to the attachments tab. I think Greg did mention this earlier on in his portion of the presentation, but Spring One Essentials is live and is free and is still available for registration. This event takes place next week, and you'll hear a lot about Spring, a lot of great things that VMware is doing. So you will see the registration link on the attachment side. So again, that's Spring One Essentials taking place January 24th to 26th. We look forward to seeing you guys there and interacting with everyone here at VMware. So let's jump in right into the question here. You've talked about many of the components required to make retail supply chain and inventory management more responsive. How portable would this be, and what can people do to make this type of architecture as portable and robust as possible?
Yeah, I'll maybe start out with that. So in terms of portability, what I will say, the general process, the general convention is, hey, people, there's lots of tools and infrastructure and standards out there. Don't do it, or don't do it yourself. Don't build your own custom platforms, right? Utilize standards like Kubernetes, like we talked about Spring and all of the power that's built into Spring through abstractions, right? So I think just in general, you want to make sure that you're using standards for your solutions, such that if you're running, especially if you're running on premise or on the cloud, again, as long as you're using those standards, you should be able to move those workloads to any one of the environments based on using these standard tools.
Yeah, I was just going to add a little bit to that and say that, that the edge locations, the brick and mortar, that side of the flow that we went through today, like I said, it can come in lots of shapes and sizes. Like it could be anything from a small single industrial or Intel NUC in a retail location to Dell servers and those sorts of things. The VMware has put a lot of time into trying to create a plane of consistency all the way down to even those small devices that you might run, not even running vSphere, for example, all the way into the cloud. So the technologies that we talked about today can be deployed across all of those form factors. And, the portability is pretty extensive if you take a look at each and every one of these, not only the technologies, but the patterns that are applied here.
Yeah, and just to piggyback on that, as you said, Michael, like, for example, using something like RabbitMQ, which was really like a cornerstone piece for data movement and data processing. And RabbitMQ can easily be deployed at the edge and with a low footprint or in the cloud. You could deploy it on bare metal, on vSphere, or in a containerized environment. And the same can be said for all of the other data products like Gemfire and Postgres. So just wanted to highlight that.
I do have a question for you guys. If anyone had any questions and wanted to reach out to you guys directly, is there a way for them to do that? Is there like an email alias they can reach out to, or would they reach out to you guys directly via LinkedIn?
LinkedIn is fine for me. I don't, we didn't have our LinkedIn credentials on the title slide, but that's perfectly fine for me as well.
Yeah, +1 on that. LinkedIn is the best way.
Yep. Yep. There aren't many Howard Twines on LinkedIn.
In our hearts, Howard, there's only one. It can only be one.
Thank you.
That's you. So it looks like those are all the questions that we have here. I do want to just plug in the December 13th talk, which was the first in this VMware Data Solutions Industry Series, and that covered small-scale manufacturing. I didn't include the on-demand recording in the attachments tab here, but I will, so you guys have the ability to view that as well. Like you mentioned, this is part 2 of that series, and we'll be seeing you guys for part 3 sometime in the near future.
Yep.
Absolutely.
Cool. I see a lot of head nodding, so it'll be great. So thank you guys for joining us today. I don't know if there's any closing remarks that you guys had before we close this out.
Look forward to the next session.
Yeah, watch this space.
Yeah, thank you for your time. Absolutely. It was a pleasure. It's always a pleasure to work with these gentlemen. And to the next time.
Great.
I think I'm going to open my own retail.
Yes.
There you go.
Mhm.
Thank you, Mike. Thank you, Howard. Thank you, Greg. It was a pleasure working with you guys again. Looking forward to seeing you guys in part 3. And most of all, thanks to all of you guys for attending it today. This event has been recorded and will be available on demand shortly after the end of this presentation. So feel free to rewatch the recording, share it with anyone that you know that may be interested in this topic. And the question line is still always open, so we can respond to those post-event as well. So thanks to all of you guys. Have a great week. I'll see you guys soon. Bye, all.
Thank you.
Yeah. Bye.